Hello everyone. In today's video I will be solving a problem based on slope deflection method. So here this is the beam which we have to analyze by using the slope deflection method. So in case of the slope deflection method, I'll write it SDM. It is the short way of writing slope deflection method. So in case of the slope deflection method, the first step is to find the fixed end moment of the beam. Okay, so I'll write this FEM. So here in the fixed end moment, first we'll solve for a span A to B. So from A to B, it's a fixed end moment. From A to B is equal to, here from A to B, point load is acting where from A it's a 1 meter distance from this load, and from this point to B it's a 2 meter. So this load is not acting equally. So in this case, what happened, the formula for finding the fixed end moment is minus W. Let the distance be A and this distance be B. Okay, so here the minus W A B square by L square. So when it's from A to B, the formula will be this one, that is minus WAB square divided by L square. So just we need to put the values here, that is W is nothing but 20 into A is nothing but 1 meter, 1 into B is 2 meter, 2 the whole square divided by L square. L is the total span of the A and B, that is 3 square. So we'll get the value around minus 8.89 kilonewton meter. And now fixed end moment from B to A. When it comes from B to A, the formula will be WA square B by L square. And here you have to remember those formulas. Okay, now we just need to put the values here. W is nothing but 20 into 1 is A is 1 square into 2 divided by 3 square. So we'll get the value around 4.44 kilonewton meter. Now for span A to B is done. Now we have to find for B to C span. So here fixed end moment from B to C is equal to, here also see this load is acting at the mid of this span from B to C. So when the load is acting like this, our formula will be WL by 8. Okay, and when we solve from B to C, that means from right to left, from left to right, then our formula will be negative. Okay, so here just we need to put the values, that is W is 30 minus 30 into L is total L length is 4 divided by 8 is equal to minus 15 kilonewton meter. Now we have to find the fixed end moment from C to B. C to B will be from here to here, then it will be positive from right to left, that is WL by 8 is equal to 30 into 4 divided by 8 is equal to positive 15 kilonewton meter. Now we have to solve for this span, that is from C to D. So here from C to D fixed end moment, so here it's a UDL. So in case of the UDL, the formula will be WL square by 12, and when we consider from left to right, then the formula will be negative, is equal to negative W is nothing but 30 and the span is 4. So here 30 into span is 4 square divided by 12, then we'll get the answer around minus 40 kilonewton meter. And last in fixed end moment from D to C, it will be positive from right to left. So WL square by 12 is equal to 30 into 4 square by 12 is equal to positive 40 kilonewton meter. Okay, so we got all the answer for fixed end moment for all the span, that is this one from B to C is minus, and from C to B is 15, and from C to D is minus 40, and from D to C is 40. Now next step, the second step is to apply a slope deflection equation, okay, for each span. So for each span, so we know the formula for solving slope deflection method, that is, and here also we have to find for each span. So from A to B is equal to fixed end moment from A to B plus 2EI by L bracket 2 theta A plus theta B minus 3 deflection. This is nothing but the delta is the deflection divided by the L. Okay, so here in this question there is no deflection, so we can directly ignore this term. Okay, so I will directly ignore this term and we'll keep the equation up to here only. Okay, so now here see we have a value for moment, fixed end moment from A to B, that is this one, minus 8.89 minus 8.89 plus 2EI, and what was the value for A to B span was 3 divided by here C, this theta A value here, as this is a fix at A point the beam is fixed. So in the fix, in my previous videos also I have mentioned, for the fixed beam the deflection, the slope will be 0. So this term will automatically 0 plus theta B something will be there as it is not fixed. Okay, so now our equation will become minus 8.89 plus 2 EI theta B divided by 3. Let it be equation 1. Okay, now for B to C span, B to A reverse, na? B to A, then again our formula will be when B to A fix plus 2EI by L to theta B plus theta A. Just we need to put all the values here. So we have already solved for the fixed end moment for B to A also, that was 4.44 plus 2EI, L was same 3, and here theta A will be 0, so we'll directly keep it like this, 2 theta B. So the equation will be 4.44 plus 2 to the, or directly we can 4 to the 4 by 3 EI theta B MBA. Let it be equation number 2. Now for span B to C, okay, this was for span A to B. Now we'll solve for span B to C. So B to C, we have a formula, that is fixed end moment from B to C plus 2EI by L to theta B plus theta C is equal to, we have a value for this one, that is minus 15 plus 2EI. For span B to C the length is 4 and 2, theta B and theta C. Okay, so it's not fixed, so we'll have some values here, so we can keep it like this. Theta B plus theta C, theta B plus theta C is equal to minus 15 plus 2EI 2EI. Here what we can do is 2 will, this one will get cancelled, 2 to the 4. Okay, suppose if we multiply this one, what will get? 4 e I theta b by 4 plus 2 e I by 4 theta c, right? So this one and this one will cancel, 2. So our equation will become minus 15 plus e I theta b plus e I half of e I theta c. So bc. So let it be equation number 3. Now again for it's a b to c. Now we'll find for c to b. C to b will also be, the equation is almost same. Okay, c to b fixed moment plus 2ei by l bracket b to c, that means 2 theta c plus theta b. Just we need to put the value here, plus 15 plus 2ei, the l is, length is 4, 2 theta c plus theta b. Now again we have to solve this one, then the equations becomes ei theta c plus half ei theta b cp. Let it be equation number 4. Now we'll solve for span c to d. Okay, just we need to follow the same equation for this one also, is equal to mcd is equal to mcd fixed moment plus 2 ei by l by 2 theta c plus theta d is equal to, the value for fixed moment from c to d was minus 40 plus 2ei. So when we solve this one, l is 2ei divided by l is nothing but 4, 2 theta c plus theta d. Then the equations will be minus 40 plus ei theta c. Let it be equation number 5. MCD. Here theta c and theta d, see in this question theta d, this d is fixed, so theta d will be 0. So we, okay, don't get confused with this one. So this is 0. Now we'll solve for mdc is equal to fixed moment mdc plus 2ei by l, that is 2 theta d plus theta c. Now here dc was 40 plus 2ei by 4 and d it will be 0, so theta c. Here 2 40 plus half of ei theta c. Let it be equation number 6. Okay, so mdc. Now the third step is to, step number 3 is to apply condition of equilibrium. Okay, so now what is the condition of equilibrium for this beam? Beam was, I'll read through the beam, A, B, C and D. Okay, from here it's a UDL and it was equally distributed, and from here to here it was like that. And what was the question? 1 to 2, 20, 30, 30, 1, 2, 2 to 4. Okay, so it was 20, 30, 30, 1, 2, 2, 2 and it was 4, I guess, right? So this was our 30 and 1 to 2 meter distance, 2 to 2 and is 4. So this was our this one. So what will be the condition of equilibrium here in this beam? The condition will be from moment from B to A. This is the center from B to C. Okay, plus moment from B to C is equal to 0, and again another equation will be about from CB plus moment CD is equal to 0. So this is our two condition of equilibrium for this beam. Now we'll solve this one first. Okay, so here BA plus MBC is equal to 0. Now MBA, we have equation. See, these are the equations. So for MBA, see, we have already MBA is for the span A to B. MBA. This is the equation. So we have equation for MBA, that is 4.44 plus 4 by 3 EI theta B, and plus for we also have the equation for MBC, that is minus 15 plus EI theta B plus half of theta C, and EI is equal to 0. So here we'll shift all the EI theta B value in this side. So write down 4 by 3 EI theta B plus, again here one more theta B is there, EI theta B plus EI theta C. Half of EI theta C is equal to 15 minus 4.44. Okay, so here what we'll get, we have to take this EI theta B as common. So the equations will be 4 by 3 plus 1 plus half of EI theta C is equal to 15 minus 4.44. Let it be equation number A. Okay, so now again we'll solve for this equation, that is moment about C to B plus moment C to D is equal to 0. So here for this 2 we already have a value, that is 15 plus half of EI theta B plus EI theta C plus for MCD is minus 40 plus EI theta C is equal to 0. So after solving we'll get this equation, that is 2EI theta C plus half EI theta B is equal to minus 15 plus 40. Let it be equation number B. Okay, so now we have to solve equation A and B. Okay, so we'll get the answer around EI theta B is equal to 1.95 and EI theta C is equal to 12.01. Now the fourth step, find the final moments. Okay, now see, we have a value for EI theta B and EI theta C. So we can put all these values in all the equation, that is 1, 2, 3, 4, 5 and 6. See, equation this we have a value for this and this, so we can put this values in all the equations. Now see, after putting all the values in those equations, we'll get the value around MAB is equal to, the equation was minus 8.89 plus 2/3 of this one EI theta B, that is nothing but 1.45. 1.45. So we'll get the answer around minus 7.59 kilonewton meter. And for like this we have to put all the values in all the equations. So I'll directly write the answer here, that is for BA will be 7.04 kilonewton meter, and here for BA, so BC will be minus 7.04 kilonewton meter, and moment for C to B will be 27.98 kilonewton meter, and moment for C to D will be minus 27.99, and from moment from D to C is equal to 46.005 kilonewton meter. So we have all the values with us now, and these are the final moments. Next step number 5 is to find the support reaction for each span. Find support reactions for each span. So first we have to draw this one, okay? From A to B, A was fixed and B is hinge, and from B to C is both are hinge support, and from it's B to C and C to D is UDL, right? UDL, and this side is fixed and this side is hinge. Here the load is 30 kilonewton and the distance is 4 meter. Here the load is acting at the middle, that is 30 kilonewton, and the distance is 2 meter by 2 meter. And from A to B, here load is acting in this side at a distance of 1 meter, and here 2 meter and 30 kilonewton. So now we have to find the support reactions for each span. So now we have to find the support reactions, okay? So now we already have this one, moment for A to B, B to A, B to C, this one B to C, C to B, C to D, and D to C. So here the moment from A to B is minus 7.59. Minus 7 point, minus means it's anti-clockwise, okay? That is 7.59. and E to B. Now from B to A it's positive 7.09. So positive means it will be a clockwise. So here 7.04. Now again from B to C, minus, so anti-clockwise 7.04, and here C to B. C to B, that means 27.98, and positive means clockwise 27.98. Now again here also it's same. C to D is anti-clockwise, then it will go this side anti-clockwise direction, that is 27.99, and this one is clockwise, so clockwise this one is positive, so it will be in the clockwise direction, that is 46.005. Now we have to find all the support reaction, that is this one, RA, RB, RC, and RD for each span. Now let's solve. Now first we'll take the moment about A is equal to 0. Moment about A means ki this all the load which is acting in this beam will come towards A. So let's solve. Minus 7, it's a anti-clockwise direction, right? So it will be minus 7.59 plus, okay, sorry, it's 20, right? So here plus downward direction, that means plus 20 into distance is 1 to reach A, 1. Again plus this is clockwise direction, so the sign will be positive, that is 7.04 minus let it be RA and RB minus RB into distance. Total distance is 3 into 3 is equal to 0. So from here we can get the value for RB is equal to minus 6.48 kilo Newton. Okay, now we have to find the value for RA. RA plus RB is equal to 20. So here in this equation we have to put this value. And how come this equation comes? That means, see, in the strength of material subject we have already discussed about this. I'll write it down again. Okay, so here what say, sum of all the forces, sum of all the upward forces, sum of all the upward forces is equal to sum of all the downward forces. Okay, so let it be sum of all the upward forces, that is upward force is RA and RB. So RA plus RB is equal to sum of all the downward forces. Here downward force only this one is acting. Here moment will not be included, only the forces will be included. Okay, so only one, that is 20. So we just need to put this value, RB value here. So RA plus RB is minus 6.48 is equal to 20. So we'll get the value for RA here, that is RA is equal to 13.52 kilo Newton. So we have a value for RB and RA for span AB. Okay, now again we have to solve for B to C span. So here from B to C, again we have to follow the same summation of all the forces towards B is equal to 0. Now here also it's a negative moment, so minus 7.04 plus, this is clockwise, 27.98 plus downward forces 30 into 2 minus RC, this is RC and this is RB. Okay, minus RC into the whole distance into 4 is equal to 0. So we'll get the answer for RC is equal to 20 minus 20.23 kilo Newton. And same like this one, we'll again get the equation like this for B to C span, that is RB plus RC is equal to 30 kilo Newton, 30. So we just need to put the value for RC here, that is minus 20.23. So we'll get the value of RB is equal to 9.77 kilo Newton. Okay, so we have this value as well as RC value here. Now again we have to solve for C to D span. Same summation of all the forces towards C is equal to 0. Then anti-clockwise minus 27.99 plus 46.005 plus 30 into 4 into 4 by 2 minus, let it be RC and RD. So RD into 4. So we'll get the value for RD is equal to minus 6.45 kilo Newton. Same, we have to follow this step to get the value for RC here. So here RC plus RD is equal to 30 into 4. 30 into 4. So we have a value for RD here, just we need to put this value here. So we'll get the answer for RC is equal to 55.5 kilo Newton. So now we have a value for RD as well as for RC. So here finally the final step to find the support, find the total support forces. Sixth step is to final support reaction, okay. So final support reaction here. So Ra value is equal to, we have a value for Ra, right? Ra is this one, 13.52 kilonewton, and Rv value is equal to, what was the value for Rv? This one, minus 6.48. let it be 6.48 plus 9.77, this one 9.77, this na. So just we need to plus 9.77 is equal to 16.25, and Rc is equal to, we have a Rc value 20.23 plus 55.5 is equal to 75.73 kilonewton. It's also kilonewton, and Rd value is 64.5 kilonewton. So these are the final support reaction values. Now the last step is to draw SFD and BMD. So I have to redraw the question here. Both the ends are fixed, and here one hinge support is there, another hinge support is there, that is A, B, C and D. From B to C UDL is acting, and here one point load, and here also one point load. Point load of 20, point load of 30 and UDL of 30. Span is 4 meter, 2 meter, 2 meter, 1 meter and 2 meter. So for this beam we have to draw the SFD and BMD. Let's draw the BMD first. A, B, C and D. So here for a point load the bending moment diagram will be like this. Okay, for this one also point load will be like this, and for UDL it will be a parabolic. So the maximum bending moment here will be WL square by 8 for a point load, WL by 4, and for this one which is not equally distributed, WAB by L is equal to, just we need to put the value here. It is considered at A, it is considered as B, and W is nothing but 20, L is the total span. So we'll get the value here 13.33, and here also we just need to put the values and we'll get the answer around 30. Okay, here also same, we just need to put the values. W is nothing but 30 into L is the 4 whole square by 8, so we'll get the answer around 60. That is BMD diagram for this beam. Now again we have to draw the net bending moment diagram. So net bending diagram we have to draw by using these values, okay. So in my previous video also I have explained you about this diagram, so you can go and check it out. So I'll directly draw by taking these values here. So here the first is MAB is 7.59, and here also from B is 7.04, it will be a little bit downer, and from its C point it will be 27.98, and the last is 46 point something, 46 here, 46. So our bending moment diagram, net bending moment diagram will be here, like this, and here it will be like this, and here will be like this. So these shaded parts are the net bending moment diagram of this beam. Okay, now we have to draw the shear force diagram. So for the shear force diagram, here we have a value these are those values. Okay, so from here we can draw the shear force diagram. So here the first is from A, B, C and D. Okay, so here 13.52 and here it's 6.48. so point load, when the point load is acting, our shear force diagram will be like this, right? Now from B to C it was 9.77 and here 20.23. so 9.77 hour, this one will be like this. And for a UDL here 55.5 and here 64.5. so for UDL, where the bending moment is maximum, our shear force is minimum. So like this. Okay, so this is negative, this is positive, negative, positive, negative, positive. so this is the shear force diagram. So this was all about slope deflection method, and in my next video I will be solving a problem based on moment area method, that is moment area method. Okay, thank you.